Welcome back to AI.Code.Cast listeners. Today's deep dive is all about a coding challenge. It might seem simple at first glance, but trust me, it gets really interesting. We're going to tackle this problem of merging two strings alternately.
Yeah. This is one of those problems that seems straightforward on the surface, but it really gets you thinking about efficient ways to manipulate strings and, of course, design algorithms, especially when those strings have different lengths.
Absolutely. So let's set the stage here. Okay.
Yeah.
Imagine you have two strings. Let's call them word one and word two. And your mission, should you choose to accept it, is to create a new string by merging them, taking letters in an alternating order, starting with word one.
For example, if word 1 is ABC and word 2 is PQR, the merged string would be ABQCR.
Okay, I think I'm following so far. But what happens if one string is longer than the other? Like, let's say word one is AB and word two is PQRS.
Ugh, that's where it gets a bit trickier. In this case, you would alternate as long as you can, which gives you ABQ. And then you just tack on the remaining characters from that longer string. In this case, RS to the end, resulting in ABQ.
Gotcha. Okay, so the leftover letters just get added to the end. That
Yeah.
makes sense. Now, let's say you're faced with this problem in a coding interview, right? Or maybe even a real project. What's the first approach that might come to mind?
Hmm. Well, I think a lot of people, they might be tempted to go with a brute force approach, right? You could try to compare the lengths of the strings first, figure out which one's longer, and then use nested loops to iterate through both strings, carefully picking out characters one by one and then, placing them in the new string.
Yeah, that sounds a bit messy, to be honest. Especially if you're dealing with, like, really long strings. There must be a more elegant way to do this.
Hmm.
What if we, think about how we actually read the merged string?
Hmm. That's a good point. We read it character by character, alternating between the two original strings.
Right, so what if we tried simulating that reading process in our code? Imagine having two pointers, like two fingers pointing at the current letter in each string. We could start at the beginning of both words.
Yes. You grab a letter from each word, add them to your new string, and then move each pointer to the next letter in their respective word. Just keep going until you reach the end of one of the strings.
And then for the remaining letters in the longer string, you just add them to the end of that merged string.
Right.
That sounds much cleaner than nested loops.
Exactly. That's what's called the two-pointer approach, and it not only simplifies the logic, but also improves the efficiency of our code.
Okay, I'm loving this two-pointer idea. So let's break down how this would actually work. Like, step by step, what would be the first thing we'd do?
Okay, so we'd start by initializing two pointers. Let's call them I and J, both starting at 0, which represents the first index of their respective strings, word 1 and word 2.
So it's like we've got two runners lined up at the starting line of a race, each ready to sprint through their respective strings.
Precisely. And we also need an empty string to store our merged result. Let's call that one result.
Okay, so we've got our pointer set up right, and a blank slate to build our merged string. What happens next?
Now we enter a loop. As long as either pointer is still within the bounds of its string, meaning we haven't reached the end of either word, we'll perform a few actions.
Okay, so this loop is where the main action happens. Tell me more.
Inside the loop, we check if pointer I is still less than the length of word 1. If it is, we append the character at position I in word 1 to our result string. Then we move I one step forward to the next character.
So if word 1 is ABC and I is 0, we add A to our result string and then increment Y to 1. Makes sense. And then we do the same thing for word 2 using pointer J, right?
Exactly. We check if pointer J is less than the length of word 2. And if it is, we append the character at the position J in word 2 to the result string. Then we move J one step forward as well.
So we're essentially taking turns, right? Adding characters from each string to our merged string. This feels very intuitive. But what happens when one of the pointers reaches the end of its string?
Well, that's when the loop condition will no longer be true, since we specified that both pointers need to be within the bounds of their strings for the loop to continue.
Got it. So once one of the pointers reaches the end, the loop gracefully ends. And we should have our beautifully merged string stored in that result variable.
Precisely. It's like those two runners we talked about earlier. They run side by side, taking turns, until one of them reaches the finish line. And then we just let the other runner finish their race, adding the rest of their letters to the result. That's a great way to visualize it. It really highlights the simplicity and elegance of this two-pointer approach.
Yeah, I'm really starting to appreciate how powerful this technique is, but I'm also kind of curious, are there any potential pitfalls, that we should be aware of when we're implementing this two-pointer method? After all, no code is perfect, right?
Oh, you're absolutely right. Even with a seemingly straightforward approach like this, there are some, common mistakes that can trip us up. And one of the most common pitfalls I've seen is forgetting to handle those empty strings.
Ah, yes, the dreaded empty string. It can really throw a wrench into things if we're not careful.
Exactly. Imagine if either word one or word two is empty, right?
Hmm.
Our merging logic needs to be like robust enough to handle these cases gracefully, without causing any errors.
So what's the best way to make our code empty string proof?
Well, it's actually pretty simple. Before we even start that main merging process, we can add a quick check at the beginning of our code.
Okay, so we'd say something like, if either word one or word two is empty, then just return the other string as the result.
You got it. That way, we avoid unnecessary processing, and we ensure that our code behaves as expected, even when dealing with those empty strings.
That's a great tip. It's like adding a safety net, right? To catch those empty strings before they cause any trouble. Anything else we should watch out for?
Let's see. Another common pitfall is what's known as an off by one error.
Off by one errors. Aren't those the ones that make you want to pull your hair out?
Yeah, they can certainly be frustrating. These errors usually happen when our, loop conditions aren't quite right.
You mean like if we accidentally tell our loop to run one extra time?
Right.
Or like stop one step too early?
Exactly. And this is especially important when we're dealing with indices like our pointers I and j. We need to be very precise about our loop boundaries, to avoid going out of bounds or missing elements.
So what's the best way to avoid falling into that off by one trap?
Hmm. I'd say the key is like careful planning and thorough testing. Before you even start writing code, take some time to just, walk through your algorithm step by step, maybe on paper, or even just in your mind.
So it's like visualizing those runners we talked about earlier,
Yeah.
making sure they're taking steps of the right size
Hmm.
and staying within the boundaries of their respective strengths.
All right.
Get it?
Precisely. Think about different input scenarios, like what happens when one string is much longer than the other, or when they're both the same length.
And of course, we can't forget to test those tricky edge cases, like, those empty strings.
Absolutely. Once you have your code written, put it through its paces. Test it with a variety of inputs, including those edge cases we just discussed.
Yeah, testing is definitely crucial. It's like giving our code a trial run, right? Before we let it loose in the real world.
Now, shifting gears a bit, let's talk about another important aspect of working with strings, character encoding.
Character encoding. I have a feeling this one might be a bit more technical.
It can be, but it's really important to understand, especially when you're working with strings that could contain like special characters or characters from different languages.
Okay, so in like simple terms, what exactly is character encoding? Or why does it matter when we're merging strings?
Okay, so at its core, character encoding is all about how computers represent characters, like letters, numbers, and symbols, as binary data, which is, the language computers understand.
I see. So it's basically a way of like translating human-readable characters into a format that computers can process.
Exactly. But here's the thing. There are actually many different character encoding schemes out there, and they don't all agree on how to represent the same character.
That sounds like a recipe for confusion. So what happens if we try to merge strings that are using like different encoding schemes?
That's when you can run into trouble. You might end up with like garbled text or unexpected characters or even errors in your program.
Okay, so mixing encodings is a big no-no. How do we avoid these encoding mishaps when we're merging strings?
Well, the key is to make sure that both of your input strings, word one and word two, and the resulting merged string are all using the same encoding scheme.
So it's like making sure everyone is speaking the same language, right, before we try to have a conversation.
Exactly. Luckily, most programming languages give you ways to specify the encoding when you're working with strings.
So we need to be mindful of this, right? And just make sure we're using a consistent encoding throughout our merging process.
Precisely. It's like making sure you're tuned to the right frequency on a radio so you can hear the music clearly, without any static.
That's a great analogy. It's amazing how even something as like seemingly simple as merging strings can involve so many intricate details.
It's all part of the fascinating world of coding. As we dig deeper, we uncover new layers of complexity and nuance.
And with each challenge we overcome, we become better, more thoughtful programmers. Speaking of challenges, let's shift gears a bit and talk about something that every coder loves, making our code run faster.
Ah, yes. Performance optimization. It's a crucial aspect of software development, especially when you're dealing with like large data sets or real-time applications where every millisecond counts.
So are there any tricks we can use to make our string merging algorithm even more efficient?
Absolutely. One of the most effective techniques is to, minimize the number of times we perform string concatenation.
String concatenation. You mean the
Mhm.
process of like joining strings together,
Yeah.
like we're doing when we build up our merged string.
Exactly. The problem is that in some programming languages, string concatenation can be a surprisingly expensive operation, especially if you're doing it repeatedly inside a loop.
So how do we reduce the number of concatenations then?
Hmm. Well, one approach is to use a special data structure, right? One that's designed for efficient string manipulation. Many languages have something like this. For instance, in Java, there's something called a string builder.
A string builder. I'm not familiar with that. How does it help?
So a string builder, it acts like a workspace for building up strings. Instead of creating a new string object every time you add a character, a string builder lets you modify a string in place. It's kind of like editing a document directly rather than making copies every time you change something.
So it's like we have this special container where we can assemble our merged string piece by piece without generating a ton of unnecessary string objects along the way.
Exactly. And this can significantly speed up your code, especially when you're working with large strings or performing a lot of merging operations.
That's a great tip. Using a string builder or a similar construct in other languages sounds like a smart move for optimizing string merging. Are there any other optimization techniques we should be aware of?
Yeah. Another helpful technique is to pre-allocate the memory for your merged string, especially if you have a good idea of how long it's going to be.
Pre-allocate memory. What does that mean exactly?
So it means reserving a specific amount of memory, right, up front,
Yeah.
specifically to store that merged string.
So instead of constantly asking the computer for more memory as our merged string grows, we just reserve all the space we need, right from the start.
Exactly. This can prevent the overhead of, repeatedly allocating and reallocating memory as the merged string grows,
Okay.
which can slow down your program.
So it's like setting up a banquet table, right? With enough chairs for all of our guests in advance,
Mhm.
rather than scrambling to add more chairs as people keep arriving.
That's a great analogy. Pre-allocating memory is a great way to boost performance, especially when you know the approximate size of the merged string ahead of time.
These optimization techniques are really helpful. It's amazing how even small tweaks can make a big difference in how efficiently our code runs.
Absolutely. It's all about understanding the underlying mechanisms, right? And making informed decisions to write, cleaner and faster code.
This whole deep dive into merging strings has been so illuminating. We've gone from, understanding the basic algorithms like that two-pointer method to exploring potential pitfalls and even delving into these optimization techniques.
And we've only just scratched the surface. There's always more to learn.
Yeah, it feels like we've covered so much ground already. Like we started with understanding the problem, right? Then we moved on to optimizing our solutions. But you know what? I'm kind of curious about the bigger picture here. Why is this seemingly simple problem of merging strings alternately? Why is it so important?
That's a great question. It's easy to get lost in the technical details like we have been, but you're absolutely right. There's a much broader significance here. You see, this problem isn't just about manipulating these characters. It's about understanding how to combine sequences of data in a structured and efficient way. And that's a fundamental concept. It pops up everywhere in computer science.
Hmm. So it's not just about strings then. Are you saying these techniques can be applied to other types of data as well?
Absolutely. Whether you're dealing with arrays, linked lists, or, any other kind of sequential data, the principles we've discussed, like using pointers to traverse data and thinking about how to handle different lengths, they're incredibly valuable. It's like having a Swiss Army knife of algorithms, a set of tools that can be adapted to a wide variety of situations.
I like that analogy. It makes me feel like we're not just learning how to solve one specific problem, but gaining a deeper understanding of how to approach a whole category of problems.
Exactly. And that understanding can be applied to so many real-world scenarios. Think about data integration, for example. Imagine you're working for a company and they've just merged with another company, and now you need to combine their customer databases.
Okay, I can see where this is going. You have two separate lists of customers, and you need to merge them into a single unified list, right?
Precisely. And you could use the principles we've been talking about today to do that efficiently, making sure that data from both sources is, interleaved correctly.
That's a great example. It makes this whole concept feel a lot more tangible. What about other areas? Like, where else do these techniques come in handy?
Hmm. Well, let's think about text processing. Applications like spell checkers and plagiarism detectors, they rely heavily on string comparisons.
Right, right. They need to be able to analyze text, look for similarities or differences.
Exactly. And the techniques we've discussed, like using pointers to traverse strings and efficiently comparing characters, they can be adapted to do things like, finding common substrings, identifying misspellings, or even detecting patterns of copied text.
It's amazing how these, like, seemingly simple algorithms can play such a crucial role in so many different areas. What about, like, more scientific applications?
Oh, absolutely. One field that immediately comes to mind is bioinformatics.
Ah, yes, the world of DNA sequences and protein analysis.
That's right. In bioinformatics, merging and aligning sequences, it's a fundamental task.
Hmm.
Researchers use these techniques to compare genomes, identify genetic mutations, and even, design new drugs.
Wow. It's incredible to think that these algorithms we've been talking about are being used to, like, unlock the secrets of life itself.
It really highlights the power of computational thinking. We can use these algorithms to analyze and understand incredibly complex systems.
This whole deep dive has been a real eye-opener, honestly.
Right.
We've not only learned how to merge strings alternately, but we've also explored, like, the broader implications of these techniques and seen how they're applied in a variety of fields.
It's a testament to the beauty and versatility of algorithms, wouldn't you say?
I completely agree. Well, I think it's time to wrap up our deep dive for today, but before we go, let's leave our listeners with, something to ponder.
I like that idea. A little challenge to keep those coding brains engaged.
Exactly. So here's a question for you all. What if we had to merge more than two strings alternately? How would you adapt the approaches we've discussed to handle, like, multiple input strings?
Oh, that's a good one. It really builds upon the foundation we've laid today, right? And it encourages you to think creatively about how to solve these problems.
Absolutely. So to all our listeners out there, we challenge you to, like, explore this idea.
Yeah.
See what ingenious solutions you can come up with. And remember, the journey of coding is all about, continuous learning and exploration.
Yeah, and don't be afraid to, experiment, have fun along the way.
Thank you all so much for joining us on this exciting deep dive into merging strings alternately. We hope you've enjoyed the ride. Until next time, happy coding, everyone.
Happy coding!